Welcome everyone once again for this new lecture on bus arbitration. So in the previous lecture, we have already seen what exactly is bus, what is its architecture, and what are the different type of bus we can have, right? So we can have data bus, address bus, control bus, and through another classification, we may have dedicated bus or multiplex bus, right? Now, whenever we talk about we are having a scenario where multiple devices are connected through a common bus, right? Or you can say whenever there is a scenario where sharing of bus is there. So now there is a question how to decide which particular device is going to use the bus. So this is the whole concept of bus arbitration to decide how the bus is going to be used. What is the schedule? What is the sequence in which the shared bus is to be used by the different devices, right? So bus arbitration is a process which decides among a number of devices requesting to use the system bus and which device is to be uh, which device would be able to use the bus, which device would get the access of the bus. Okay. So this is the whole objective of this bus arbitration. So it refers to the process by which the current bus master. So uh, first of all, what is bus master? So all the devices here we are calling them as a bus master, right? So current bus master accesses and then leaves the control of the bus and passes it to another unit or another bus master. Okay. So bus master is something the controller that has the access to a bus at any particular instance, right? So if let's say device 1 is having the access of the bus, so we'll call it bus master. If device 2 is having, then it is going to be the bus master and so on. Bus arbiter is something. It is something. It is also known as bus controller. Okay, so it is going to decide who is going to be which device is going to be the current bus master, which device would be having the access of the bus. Now there are two approaches. So one is centralized bus arbitration. So in centralized bus arbitration, we are having a system which is being controlled by some sort of centralized controller. Okay, that we are here we are calling it as a bus arbiter. So obviously when we talk about any centralized system, so it is having a single point of failure, right? So the overall process is going to be faster, but it is also having a single point of failure. Another approach can be distributed bus arbitration. So in distributed bus arbitration, all devices which are connected to the system bus is going to participate, right? Now there are three methods, three very popular methods for this centralized bus arbitration that we'll be discussing. So one is daisy chaining method, another one is polling method, or it is also known as rotating priority method, and third one is fixed priority method or independent request method. So every method is going to have some pros as well as cons. So daisy chaining, as the name suggests, it is some sort of chain would be created. So in this method, what happens? If multiple devices are connected, so the device which is closest to the bus controller, it is having the highest priority, right? So the closest device will get the uh, priority in the whenever the controller is granting the bus, and the device that is far away from the bus controller, so obviously it is having the least priority. Now there are three types of control signals would be there. So bus request. So whenever any device is accessing the bus, so it will put its request on the bus request line. Whenever any device has become the bus master, it has gained the control of the system bus, so it is going to enable this bus busy line so that other devices would have the information. Yes, at this particular time, bus is busy. And third one is bus grant. So bus grant line is being used by the bus controller to inform a particular device about granting the bus. Now we'll be discussing this. So here you can see what we are having. So we are having a bus controller. There are certain lines. So one is bus busy line, other one is bus request line. And you can see here every device, right? Every master is connected to these two lines, bus request line and bus busy line. So any device can request for the bus, and any device can have the bus grant. Now this bus grant line is, you can see, as master 1 is closest to the controller, so it is connected to this controller bus grant line is connected to master 1, then master 1 bus grant line is connected to master 2, and so on. So what is happening here? Let's suppose master 1 is requesting for the bus. So it will put its request on this bus request line. Now controller will see the request, and what it will do, it will send a bus grant signal to master 1. Right. So as soon as this master 1 receives the bus grant signal, it will enable this bus busy line. Okay. And use the system bus for transferring the data. Now when master 1 has completed its task of transferring the data, it will disable this bus busy line. That means now bus is free. All right. Now suppose at this point of time master 2 has sent the request. So this master 1 will forward the bus grant signal to master 2. Okay. So you can see here, like whenever there is a request from any, let's say master n, okay, the last device wants to access the bus, so it is having the least priority. So it will get this bus grant signal only when the previous n-1 devices, none of these previous n-1 devices is using this bus. So it is having the least priority. So here the priority of the device, the priority of the master is actually decided by its physical location, how closer it is to this controller, bus controller. Right? Advantages are it is cheaper, it is simple, less number of lines would be required. Disadvantages, slow arbitration time. Why slow? Because if master n wants to have this bus grant signal, so this signal will propagate through all these n-1 devices. So it will take some time. Now the priority is depending on the physical location, right? And chance of failure is more. Why chance of failure is more? Let's suppose master 1 gets failed, right? So it will actually block this bus grant signal. So uh, all the all the next n-1 devices are actually depending on this master 1. Okay. So the next method is polling method or rotating priority method. So what happens in this polling method? So there are certain lines which are called as polling lines that would be used to give the grant to a particular master. Okay. Now what is happening here? The priority is actually decided by the bus controller, and the bus whenever the bus controller is having any request for the bus, so it will send the bus grant signal through these polling lines, right? So if we are having n number of polling lines, so uh, we may connect 2 raised to the power n devices to this system. Okay. So if we see through this diagram, so you can see here there is a bus controller, and there are certain devices, master 1, master 2, and there are n number of devices that are connected. Now all these devices are connected to some lines which we are calling as address lines or polling lines. Okay. So whenever, let's suppose master 1 wants to use the bus, so it will send a bus request to this controller. Okay. Now bus controller is having some priority logic that is already there. So it will use this logic, it will see all the requests that are coming at a particular time, and on the basis of those requests, it will grant the bus to a particular master. Let's suppose master 2 is having the highest priority, so it will grant the bus to this master 2 by putting its address. Okay. Now let's suppose this there are three address lines and the address of the master 2 is 001. So this bus controller will put 001 on this address line. Now once this master 2 will see its address on the address lines, so what it will do, it will immediately enable this bus busy signal and it will start using the bus. Okay. So the rest of the process would be same as the daisy chaining method. The only difference is here the priority is not decided by the physical location. It is pre-decided by the bus controller. Advantage is fast arbitration, simple, less chance of failure. Again, master 2 is not dependent on master 1. Even if master 1 gets failed, so it would not affect master 2 and rest of the devices, right? Then disadvantages. So if we want to have more devices attached to a particular bus, so we need to use more address lines, or you can call it polling lines, right? And the last method is fixed priority or independent request method. So as the name suggests, there is not going to be any dependency among the devices, right? Now the priority is already fixed. Priority for all the devices that are connected to a particular bus, that is already fixed. Okay. And that logic is already there in the bus controller. And every request is going to be independent. Okay. Just look at this diagram. So what we are having bus controller. Now you can see every device is independent. How it is independent? Every device is connected to the controller through a separate bus grant and bus request line. So you can see for master 1 we are having bus grant 1, bus request 1. Similarly for master 2, bus grant 2, bus request 2, and so on, right? So again, let's suppose master 1 and 2 both wants to use this bus, so they will send their independent request to the controller. Controller is already having their priority, so it will decide out of this master 1 and master 2 which is having the higher priority. On the basis of that priority, it will grant the bus, right? So it will send this bus grant signal. Let's suppose master 2 is having higher priority, so it will enable this bus grant 2 signal. So once this master 2 will see this bus grant 2 signal enabled, it will immediately enable this bus busy line and start using the bus. Okay. So then it will transfer the data, and once the data transfer is over, it will again disable this bus busy line. So obviously this method is faster. Why? Because every device is independently connected. Very less chance of failure. Again, there is no dependency among the devices. So even if, let's suppose, master 2 gets failed, so it will not affect the other devices. Cost, obviously it is going to be high because we need more number of lines. If we are having n number of devices, obviously we need 2n number of lines for only for bus request and bus grant. So obviously it is going to affect the whole cost of the system, and there is a chance of starvation also. Why I'm saying there is a chance of starvation? Let's suppose master there is a fixed priority, right? So suppose master 2 is having the highest priority. So at one point of time, suppose master 1 and master 2 have sent the request. So obviously master 2 is having higher priority, so it will get the bus. Now again, next time again there is a request from master 2 and master 1. So again, master, as you know, there is a fixed priority. So again master 2 will get the bus. So there may be a situation when master 1 would never get to access the bus. So that is this situation we are calling as starvation. So there is chance of starvation in uh, case of fixed priority or independent request method. So this is a disadvantage. So these were the different type of bus arbitration. Uh, this is all for this particular lecture. So okay, I'll see you in the next class. Thank you.